Hi, in this video, we will look into topic 5, which is on the bottom-up parsing and a parser generator. Before this, we have learned on the top-down parser. So in this chapter, we look into the other way around, which is bottom-up parser. Okay. So bottom-up parser is normally called as a shift reduce parsing. Okay, so we look into the introductions of it to see what is it. Okay, so bottom-up parsing involves two fundamental operations. There are two: shift operations and reduce operation. So that is why the name is a shift reduce parser. Okay, so shift reduce parser actually is the bottom-up parser. It means that it's from the input string, and then you need to get into the start symbol of the grammar. You need to pass it until you get the start symbols of the grammar. So what is a shift operation? Shift operation is a moving an input symbol to the stack. Okay, so this is shift operations. For reduce operations, what we do actually is replacing the symbol on the top of the stack with a non-terminal. So there are two operations under the shift reduce parser. Shift, moving the input into the stack, and reduce is to replace. So that is the keyword. One is moving. Moving means that you push the information, push the input symbol. Okay, while reduce is replace. We want to replace the symbol on the top of the stack with a non-terminal. So this process we call it as a shift reduce parser. Okay, let's look into this example of grammar 22. Okay, so each step will be either a shift or reduce. Okay, in order to do the shift reduce, each step will either shift or reduce. There are only two operations. The algorithm accepts the input if the stack can be reduced to the starting non-terminal when all of the input string has been read. So what does it mean? From the input string, you want it to be able to parse to reduce until you get the starting non-terminal. Means that this is, in this case, G22, your starting non-terminal is S. Okay, so if you look into this derivation tree, the input symbol is C, A, B, A, B. So from this input symbol, we want to be able to reduce it until we get lastly is S. So that is bottom up. Means that from the input symbol, you pass it until you get the input symbol. While in the top-down parsing, normally you start with grammar and then you derive the input string. Okay, let's see into this example. The string of symbols being reduced is called a handle, which is underlined here. Okay, so the string of symbol being reduced means that the string that is used being used to reduce, we call it as a handle. So in this case, if we go from left to right, is a top down. If you go from right to left, we call it a bottom up. So in this chapter, we are interested in the bottom up approach. So we start from the one on the right hand side here, which is your input string. So the input string here, C, A, B, B. Okay, so we want to be able to reduce it until we get S. So how do we do that? We start to read from the right hand side of the string, which is C. So look into your grammar. On the right hand side of your grammar, is there any derivation on the right hand side? Here is C. So on the second rules, okay, on the second rules, S goes to C. So means that you need to reduce this C to S. So that is what it means by reduce. So the handle here is C. C is the one that handle these operations. So C, you underline it. C is the handle. C is the one that is used to reduce. So using a C, you reduce it become S. Okay. Now we move to the second part here, the derivations. So you normally read it from the the left hand side. Sorry, almost left hand side from the left. Okay. So as you look into the S, there is no rules there on the right hand side of the rules that SA also you don't have it. SAA also you don't have it, but you have AB. Okay, AB. So AB is rules number 3. Rules number 3 say that if you have AB, you can reduce it become B, a non-terminal B. So AB is a handle. Okay, so you reduce it become B. AB become B. Okay, now we move to here. And again, you read it from the left hand side and see whether you can get a combinations of a string that you can reduce from. So in this case, it's a SAB. If you look into the first rule, SAB, you can reduce it become S. So SAB is a handle. So you reduce it become S. Now we look into this string. We only contain 4 now. It's been reduced. Next handle is AB, which is rule number 3. AB can be reduced into B. Okay, so next one is SAB. SAB is rules 1. You can use all of this and reduce it become S. So now you get S. So that is what we call as a bottom-up parser using a reduce operations. Okay, we start from the right to the left in this derivation tree. Okay, now we want to be able to store this information into the sequence of stacks. Okay, how did we want to parse this CAABAA using grammar 22? So here is the grammar. So it says here, if a grammar, if we look into the sentence here, if the parser for a particular grammar can be implemented with a shift-reduce algorithm, we say the grammar is LR. LR means that when you do a parser like this, the stack parser here, the stack frame, at the end you get accept status here, means that this grammar is called LR. LR stands for L is reading input from the left and right is finding a rightmost derivations. Okay, so actually you are reading from the left. Okay, CAABAA, you read it from C, is a left derivations, but you're finding a rightmost derivations. Okay, so if you, after you have go through this sequence of stack frame and at the end you did not get accept, so it means that this grammar is not in LR. So it's not in LR. So bottom up normally work for LR grammar. Yeah. So how to do it? Shift and reduce operation using a stack frame. Okay, so if you see here the stack frame, we do it horizontally. Okay, means that you a bit light down the stack. Okay. So this is all the stack. So as normal, you start the stack with a triangle symbol, which is the start of a stack. Okay, and then this is your input. This is your input. Okay, the one shift and reduce here is the action. Action. The operations or action. So whether you want to shift or whether you want to reduce it. So how to do it? So you start with your input. Your input here in this example, it mentioned your input is CAABAAB. So you write down your input here. CAABAAB and end marker. Okay. So the first operations is you need to shift the input into your stack. So push your the first string of your input string into the stack, which is C. So you shift it inside the stack. So we call it shift. Okay. Now you want to check. After you shift, you need to check whether the one inside your stack actually is there any on the right hand side of the grammar that is similar to the one inside your stack. So in this case, inside your stack you have C. Is there any on the right hand side of grammar content C? Yes, which is rule number 2. So if yes, then what does it mean is you need to replace this C with S. That's what it means by reduce. When you found C, you need to reduce it become S, following rules number 2. So that's why here you say reduce using rules 2. Okay, that's done. When you reduce means that you actually replacing the C with S. Okay, so here on the third stack, you have S inside your stack. Okay. You can check inside your stack S, is it same with the one on the right hand side of grammar? No. So if no, then you need to shift another input. So in this case, you need to shift. The next input is A. Okay, so you write down the shift. So the one in your stack is SA. So now you check inside your right hand side of your grammar, is there any SA? No. If no, you need to shift again another input, become SAA. So check if there any SAA or A or AA inside your right hand side of your grammar. No. If no, then you need to shift another input into your stack. Now you check, is there any SAAB? No. SA? No. AA? No. AAB? No. AB? Yes. So you can use this AB, A and B here. Okay. Using rule number 3, you can replace that AB become B, a capital letter B. So you write down there, reduce using rules 3. Okay, so what does it do? AB, you change it become capital letter B using rule number 3. Okay, done. After you have shifted that, then you can check it again. Inside your stack, contain SAB. Is it same with the one on the right hand side of your grammar? Yes, which is on rules number 1. SAB can be reduced to S. So what you do is reduce using rule 1. So you are replacing SAB become S. Okay, now you check, is S can be reduced? So you need to check on your right hand side of the grammar, is there any S? No. Okay, if it's no, then you have to shift another input again. So become SA. So is there any SA on the right hand side of the grammar? No. So you have to shift again another input, become SAA. Is there any SAA? No. Then you have to shift again the input inside your grammar. Now, yes, now it is the same with the previous step, which is SAAB, means that you can reduce AB into B using rules number 3. So write down there, reduce using rules number 3. So you are replacing AB into capital letter B using rules number 3. Okay. Now check, SAB, is it can be reduced? Yes, it can be reduced. So look into the grammar on the right hand side. They contain SAB. It can be reduced to S. So write it down. Reduce using rules number 1. So SAB now become S. Okay. Alright, so you check now. For your input symbol, is there anything left? No. No more input symbols on your input stack here, normal input symbol here. Okay, what does it mean? You have read all the input symbol, and it says if you have read all the input symbol and you on the stack you already reached the start symbol, which is in this case is S, means it is on the accepting stack. Yeah, accepting stack. So here you write down accept. Because no more input symbol. In order to be accept, no more input symbol, and the one inside the stack is the start symbol. So that is called accept. Yeah? So that is how you do the shift and reduce operations using grammar G 22 and 22. Okay, there is also a case that when there is a conflict, means that you do shift and reduce, but you didn't get into the accepting status. There are two reasons. Okay, there are two reasons. One, okay, if you look into this example, grammar 23. Okay, this is the grammar 23. If you, okay, let's say we go through this stack frame. Okay, so let's say this is the input for A, B. Okay, you start with A, so you start by shifting the input, first input A. Okay, now if you look, then you need to check into your right hand side of grammar. Is there any A on the right hand side? Yes, which is rules number 2. So you reduce using rules number 2. Okay, done. So when you reduce, what does it mean? Is replacing the A with S, right? So you have S. Okay, now we're already on the third stack. Third stack, you need to check whether on the right hand side got a S or not. No. Okay, if it's no, we cannot accept first because we still got some more input string here. Then what we need to do is to shift another input string. So SA, okay, SA, okay, you can reduce, okay, using a rules number 2 because you have A here. A can be reduced using rules number 2. A can be reduced using rules number 2, reduced to S. Okay, when we reduce it to S, you get this S. So SS, the original S, and also the S when you reduce A. Okay, and then you have now you don't have SS on the right hand side. You need to shift another input here. Okay, which is this is S is capital, yeah. So SSA. Okay, SSA. All right. So you can reduce or you also can shift. Okay, for example, they choose to shift. Yeah, if you choose to shift, then you get SSAB. Only then they reduce here using a rules number 3. AB become B. Okay, so there is actually a conflict here where you didn't actually get into accepting state, accepting mode. Yeah, so because of this conflict, you actually can choose whether to shift or to reduce at some point in the stack. Like in this case just now, SSA, you can choose actually to reduce, but in this example, they shift it. Okay, they shift it to become AB. So there is a conflict there. So you didn't know actually which one actually will get to the accepting stack. Okay, so there is a grammar that make us shift reduce conflict. Okay, so the second example actually here occurs when there is a more than one grammar rules whose right hand side match the top of the stack. So in this case G24, if you look into rules number 2 and 3, on the right hand side both is A. So when we want to do a parser, we actually confuse. Okay, for example in this case they go for AA, so you shift A. So if you check A on the right hand side, there are two rules, rules 2 or rules 3. So there is conflict also whether to choose rule number 2 or rules number 3. So we call this as a shift reduce conflict. So there are two situations where the shift reduce conflict can happen. Okay, how to resolve the shift reduce conflict? Shift reduce conflict can be reduced first by all shift reduce conflict could be resolved by shifting rather than reducing. Okay, what we did previously, if you see the one in the stack that equals to the one on the right hand side of the grammar, you normally will reduce it. Okay, but at some point when you come to the end of the stack, you didn't reach to the accepting state. Okay, so what you can do actually is instead of you reducing it, you also can choose to shift it first. Okay, you can try it on this grammar 23. Instead of you reducing it on the stack number 2 here, try to shift it. Okay, means that you add another input to it and see whether you can get accepting state. So that is one of the way. Okay, so it is like a trial and error. Okay, so if this assumption always yield a correct pass, there is no need to rewrite the grammar. But alternatively, if that also doesn't work, means that you already shifting it rather than reducing, but you also didn't get to the accepting state, means that you need to rewrite the grammar. So that is two ways to resolve a shift reduce conflict. Either you need to shift or you need to rewrite the grammar again. So there is two ways to do it. Okay, so this is just an extra exercise on how actually to construct the sequence of stack and input configurations. Okay, so just go through with using a grammar G22. So this is a grammar G22. So for example, we need input string is CAAB. So we start with the initial stack, which with content triangle starting symbol. Okay, so the first step is always shift. Okay, we shift it because it's empty in the stack. So we shift C inside the stack. After we shift, we need to check content inside the stack whether it is equals to the one on the right hand side of the grammar. So in this case, yes, it is equals on the second rules. Okay, so if it is equals, then we say reduce to using rules 2. So when we reduce means that we are replacing the C with S. Okay, so this follow rules number 2, means that you're replacing C with S. And then after you replace, you can check it again. Maybe it can be reduced further. Is there any S on the right hand side of the grammar? No. So if no, you just shift another input in. So SA. Okay. Is there any SA? No. Then you can shift another input. So become SAA. Okay. So this here is less one string. So SAA, is it equals to the right hand side of the grammar? No. If no, then you shift another input. Okay, now you have SAAB. Okay. Now if you see in your stack, you don't have SAAB on the right hand side. You don't have SA. You don't have SAAB. SAA. You don't have AAB, but you have AB. Okay, AB. AB using rules number 3, you can replace it with P, capital letter P. So reduce using rules number 3. So AB become B. So now the new stack have SAB. Okay, now you check whether SAB is on the right hand side of your grammar. Yes, using rules number 1, you can reduce SAB become S. So you say here on the action, you have reduce using rules number 1. So SAB now become S. Okay. Now you can check whether S is on the right hand side or not. No. But you also can check whether you still got an input symbol or not to be shift. No. Now S is the start symbol of your grammar and you have no more input symbol, so you are in accepting state. Okay, so that is how actually you run through a sequence of stacks, okay, for a grammar. So in order to have these configurations, you need what we call a stack. Yeah. We need to have input symbol. And this one, shift and reduce, is the operations. 3 informations. Or we can call it actions. Whether we want to do shift or reduce. So there are 3 informations, important information, to have to develop, to construct sequence of stacks and input configurations. Okay, so that is the answer of this subtopic on the shift reduce parsing. Thank you very much.